Hi, this is Mrs. Youd, and today I'm going to teach you Chapter 10, Lesson 4, which is about zero and negative exponents. It's very important that you have watched the other videos from Chapter 10 before continuing with this one, because I expect that you will have already learned and know the other rules for exponents that you learned in previous sections. In sections 2 and 3, you learned about the first 4 rules of exponents. Today we're going to do 2 rules, and the first one is rule number 5, zero exponents. So to explain zero exponents, let's first go back and remember what 4 to the power of 3 is. So 4 to the power of 3, this exponent 3 tells me to multiply the base, which is 4, 3 times. So that means 4 to the power of 2 would be 4 times 4, because that's twice that we multiply 4 together. And 4 to the power of 1 would be just 4, because it's just 1 time. We could also say that all of these are also multiplied by 1, because multiplied by 1 does not change the answer to the problem at all. The reason why I did that is because it helps us understand what 4 to the power of 0 would be. So 4 to the power of 0 means that we have 0 4s, but we still have that 1 left over. So 4 to the power of 0 is 1. And the general rule for zero exponents is that anything to the power of 0 equals 1. The only one that this does not work for is 0 to the power of 0. That is undefined, which means that A cannot equal 0 for this kind of problem. So the general rule is anything to the power of 0 is 1, except 0 to the power of 0. Rule number 6 has to do with negative exponents. To understand negative exponents, let's first look at 4 to the power of 3 over 4 to the power of 5. So if we remember, 4 to the power of 3 is 4 times 4 times 4. There are 3 of them, because the exponent tells me that there are 3. 4 to the power of 5 means we multiply 4 together 5 times. So in our previous video, we never had more of the numbers on the bottom than the top, and before we had always had more numbers on the top. So what's going to happen here is that we are going to cancel these first 3 out, because 4 divided by 4 is 1, and you'll notice that there's nothing left on the top. So we do have to have something on the top, and whenever you don't have anything left, you at least need to put a 1 up there. So then we have 2 4s left on the bottom, so I'm just going to write 4 squared on the bottom. Okay, so let's think about a different way to do this same problem that we've learned before, and that is that whenever you have a quotient like this, you need to subtract the exponents. So this would be 4 to the power of 3 minus 5, which is 4 to the power of negative 2. So what that tells us is that 4 to the power of a negative 2 is the same as 1 divided by 4 to the power of a positive 2. So the overall rule for this is that any number to a negative exponent, so we're going to do a to the power of negative n, is equal to 1 over a to the power of positive n. And so this is the overall rule. Once again, a cannot be 0, just like in the previous one. The reason why a cannot be 0 is because if we had something like 0 to the negative 4, that would become 1 over 0 to the positive 4, which means 1 over 0 times 0 times 0 times 0 is 0. And of course, you're not allowed to divide by 0. So this ends up not being allowed. So that means that you can't have that number be 0. All right, let's work on some examples. In number 1, I have 4 to the power of negative 2. So that is the same as 1 over 4 to the power of positive 2. The reason for this is what we learned on the previous page, is that anything with a negative exponent means that the whole thing gets moved underneath and the exponent becomes positive. So a common mistake that I see is a lot of students see a negative exponent and they want the whole problem to be negative. So they would change this to negative 4 squared or negative 1 over 4 squared. But all of these are incorrect. Whenever you have a negative exponent, all it means is that it gets moved to the denominator and the exponent changes to positive. So these are incorrect over here. To finish this problem, we're going to finish it by multiplying 4 times 4 because that's what 4 squared is. So the final answer is 1 over 16. On question number 2, we have a negative exponent again. So that means we're going to have 1 over, and the whole base there, which is negative 2, now goes to the denominator, and the exponent changes to positive. So it's negative 2 to the positive 5 now. So what that means, remember, is that we're going to multiply negative 2 5 times. So negative 2 times negative 2 is positive 4, and this is also positive 4, so we're at 4 times 4, which is 16, and then we need to multiply by this negative 2 again. So 16 multiplied by negative 2 is negative 32. So my final answer is 1 over negative 32. In number 3, we have 6 to the negative 8 multiplied by 6 to the positive 8. In a previous video, you learned that when you have the same base, in this situation, we're going to add the exponents. So that would be 6 to the negative 8 plus 8, which is 6 to the power of 0. Anything to the power of 0 is 1, as you learned from the previous page. This was one of the new rules that we learned today. Remember, anything except 0 to the power of 0 is 1. For number 4, in a previous video, we learned that whenever we are dividing, so we have a quotient this time, we have the same base, negative 3, and we have two exponents here. So remember, what we're going to do in this case is subtract them. So that gives me negative 3 to the 5 minus 6, which is negative 3 to the negative 1. Once again, we have a negative exponent, so we need to move the base, which is negative 3, to the denominator, and the exponent becomes a positive 1 instead. Now, we don't really need to write that positive 1 there because it just stays as negative 3. So we can just leave this as negative 3. We don't even need the parentheses around it anymore because the exponents are gone now. There's a couple of ways to think about number 5. I'm going to show you one of them. Whenever you have a negative exponent, notice we have a negative 4 here, this whole piece is this time going to go to the numerator, and the exponent was going to become positive. So this is going to stay 1 over 5 to the 7th, but this time on the right side we're going to pull the 5 to the power of 4 to the numerator, and we can go ahead and put that over 1 if we want to, but we don't need to. So now we're going to multiply straight across because these are fractions, so it'll be 1 multiplied by 5 to the power of 4 over 5 to the power of 7 multiplied by 1. So now what we're going to do is subtract our exponents because we have the same base here. So it'll be 5 to the 4 minus 7, which is 5 to the negative 3. Okay, so now we have a negative exponent again, so we're going to pull the base to the denominator and make the exponent positive. And 5 times 5 times 5 is 25 times 5, which is 125. So the final answer is 1 over 125. I know that this feels like a whole lot of steps, but once you get better at doing these problems, you'll be able to skip a lot of the steps. For example, you'll probably can skip this one, and you might even be able to skip this one as well. I'm just showing all of the steps in here to make sure that you understand. Let's move on to number 6. 4 to the power of 5 multiplied by 4 to the power of negative 3. Remember, we need to add the exponents, so this would be 4 to the power of 5 plus a negative 3, and that's all divided by 4 to the power of 2. So on the numerator, we have 4 to the power of 5 minus 3, which is 2, all over 4 to the power of 2. So there's two ways to think about this. Since they're exactly the same on the top and the bottom, they can be canceled and we know our answer is going to be 1. Another way to think about this is to subtract the exponents, so 4 to the power of 2 minus 2, which would be 4 to the power of 0, and anything to the power of 0 is 1. But like I said before, you could have skipped these two steps here, because 4 to the power of 2 divided by itself always cancels them out, and we would get 1 as an answer. On number 7, we have b to the power of 0 multiplied by b to the power of negative 10. Well, b to the power of 0 is 1, so we can just put that here. Then we multiply that by 1 over b to the power of positive 10 because we have a negative exponent here. So that just gives me an answer of 1 over b to the 10th. There's really nothing more to simplify on that one. Another way to think about this same problem is that we could think about it as b to the power of 0 plus a negative 10, which is b to the power of negative 10, and that brings us to the same answer there. On number 8, we're going to leave the 8 on the numerator because it is not affected by this negative exponent, and the only thing that gets moved down is the x, so x to the power of now positive 2. There's nothing more to simplify on that one, so we can just leave it. I just wanted to show you a common mistake that I see students make on these type of problems. They think that everything gets moved down. So a lot of times students would say that this would be 1 over 8x squared, and that is incorrect. The only way that that would be correct is if we had parentheses around both the 8 and the x. Now this would equal 1 over 8 squared times x squared, which would be 1 over 64x squared. So it's remember those parentheses, I've talked to you about them before, they're super important. If you don't see them, then just assume that only the part that is connected is the piece right before the exponent. Okay, 5 more examples in these kind of problems. On number 9, we're going to look at our z's. Those have the same base, so that means that we can do something with them. This problem, it's a little bit easier to think about it in expanded form and not just by the rules. So there are 6 z's on the top and 9 z's on the bottom. So that means that we're going to be canceling out the same ones. So this cancels to a 1, these two cancel to a 1, and so on. And then when we figure out how many we have left over, we can see that we have 3 z's and they're left on the denominator. So that means we have nothing left up on the numerator, so we have to put a placeholder 1 up there. We have a 15 still left there, and we have 3 z's, so it's z to the power of 3. Now, you don't always have to think about this in expanded form, because once you get better at doing these type of problems, you can just think, okay, there's 6 on the top, there's 9 on the bottom, we need to subtract these, so that means that there's going to be a negative 3. Well, that means that they stay on the denominator, and so here we have them on the denominator as a positive 3. So once you get better at doing these kind of problems, you won't have to do all of this work here. You'll just be able to think about it logically and to understand the concepts that are going on. On number 10, we have 19x to the negative 6. Remember, we have negative 6 and it only has to do with the part that's right before it, so it doesn't have to do with the 19 unless there were parentheses there. We don't have parentheses, which means that only the x is affected by the negative 6. So that means that the 19 does not get affected. It stays on the numerator. The x moves to the denominator and becomes a positive 6 as an exponent now. And there's nothing left to do on this one, so that is completely simplified. On number 11, we have a to the negative 5 over a to the negative 8. So that means that we need to subtract those, or we can think about them as flipping them, because since they're negative exponents, we can flip them. So that means we have 14 that's unaffected, it stays on the top. A to the positive 8, that was down here, now goes to the numerator and becomes a positive exponent. And the other part, a to the negative 5, goes on the denominator and becomes a positive exponent down there. So now we have a to the positive 8 over a to the positive 5. We need to subtract those. 8 minus 5 is 3. So my final answer would be 14, a to the power of 3. For number 12, we have 3 multiplied by 8, which is 24. And then we have t to the 6th multiplied by t to the negative 6th. So that means we can add those exponents. So we have t to the 6 plus a negative 6, which is t to the 0. Now remember, we learned in this lesson that anything to the 0 power is 1. So this is the same as 24 multiplied by 1, which of course then equals just 24. There's a lot going on number 13. The first thing I'm going to do before I try to combine anything together is I'm going to move my negative exponents to the other parts. So in this case, I have 2 that are on the numerator. They're going to go now to the denominator. So I still have a 12 on the top. I still have a y to the power of 3 on the top. Now on the bottom, I have my x squared y to the power of 5 that were already there. They're here. Now what we need to do is move these two pieces down to the denominator. So that's going to be x to the positive 1 and 4 to the positive 2. Okay, so now we can start thinking about combining these together. Okay, so I'm going to start combining the like bases now. So I see that I have y to the power of 3 over y to the power of 5. If you remember back in number 9, when you had the same base, z to the 6th over z to the 9th, we subtracted them, right? 6 minus 9 was 3, well, negative 3. And so that means that it stayed on the denominator and was a positive 3. Same thing happens here. You have 3 y's on the top, you have 5 y's on the bottom. So that means you're going to subtract them. 5 minus 3 is 2. But since the bigger number's on the bottom, that means that's where the y's stay. So we have y squared on the denominator. Let's take a look at our x's. We have these two here, x squared and x to the power of 1. Since they're in the same area, we want to add the exponents together this time. So we have 2 plus 1 is 3, so that would be x to the power of 3. Okay, so now I have my 12 left on the top, so I'm just going to put that here. And I have my 4 squared, which is 16 on the denominator. I'm almost done. The last thing that I need to do is simplify this fraction. 4 divides into both 12 and 16. So if I divide by 4 on the top and the bottom, 12 divided by 4 is 3. So I have a 3 left on the top. 16 divided by 4 is 4. And then y squared, x to the power of 3. And there we have our final answer. So this concludes today's lesson of Chapter 10, Lesson 4, which is 0 and negative exponents.